Hey, welcome back to Math with Patrick and Quill. Today is May 2nd, and we're solving problem number 122 from the Daily Epsilon calendar. And we need to show why this limit right here is equal to the number 2. So, at a base level, what a limit is, all it's saying is that if we plug in a number close to 1, we should get a number that is close to 2. And for most functions, most nice functions out there, this whole limit notation doesn't really mean much. And here, I'll just show what I mean. If we have the squaring function, where if we input some number, say 3, we square it and get 9. If I plug in something that approaches the number 3, like 2.9999, I'm basically going to get 9. I'm going to get some number right below it as 8.9999, something like that. So if I wrote this with limit notation, I could say the limit as x approaches 3 of my function f of x, which I guess I could write as x squared. This is equal to the number 9 because as x approaches 3, my output value is approaching 9. There's not anything really special going on with this function. Sometimes, though, you might get weird, say, rational functions that might look like, say, this. And I could ask, what's the limit as x approaches, say, negative 2? And I'm building this one very, very particularly, because if you notice, if you just directly plug in this negative 2, where all of these x's are, we're going to get 0 times 3 over 0. And then anything times 0 is still just 0. And so we get this weird indeterminate form of 0 over 0, because dividing by 0 is a big issue in normal math. You're not really allowed to do that. It's undefined. Doesn't really work out so well. So if I'm just directly plugging in my negative 2, and I'm getting 0 over 0, that's showing me that I need to use slightly more advanced techniques. And here, basically what I do from the get-go is I would cross off these common factors. Now, it's a little bit iffy, because if you think about going down here, and we have this 0 times 3 over 0, it's almost as if I'm crossing off these zeros, and this step isn't allowed. You're not allowed to cross off a 0 like this, because it's almost as if you're claiming that dividing by 0 is okay, and it's usually not. So it's almost like you're stretching the rules here about what you're allowed to cancel, like what factors you're allowed to cancel. But since my x is approaching negative 2, it's not actually equal to negative 2, I know that these numbers are technically not 0. They're just really, really close to it, but there's still some number that's not 0. So that's a long-winded way of just saying I'm allowed to cancel factors like this first, and then try to plug in the negative 2. And here it's no issue. If I just plug in this negative 2 directly, I'm going to get the number 3. There's no issue with the number 3. So if you tried graphing this function, I'm not exactly sure what it would look like, but once you're approaching the number negative 2, you're going to get the value, or you're going to approach the value 3. So maybe it looks something like this. And right here at this specific spot, it's undefined, because we're doing 0 divided by 0. But everything around it is kind of telling you that, hey, we are approaching the value 3. So let's take these ideas into this current problem. I just want to see what happens when I directly substitute in that 1. I'll probably get some kind of indeterminate form, and then I need to figure out somehow how to cancel out some factor, I'm hoping. That way I can evaluate the rest. So with just direct substitution, it looks like I have the square root of 1 minus the the sixth root of 1, divided by the square root of 1 minus the cube root of 1. All of these are just evaluating to 1. Any nth root of 1 is just itself. Kind of to think about it another way, 1 to the power of anything is just 1. So if you put a 20 here, you can put a 20 here. You can put any number you want, really. And any root of 1 is just itself. So with direct substitution, I'm getting a 0 over 0, and that's an issue. That's undefined. Direct substitution doesn't seem to work out. So I need to do some clever algebra strategies, I think, to somehow cancel out a common factor on the top and bottom to kind of remove this 0 over 0 issue. I think for starters, I want to see if I can factor out a square root of n from the top and a square root of n from the bottom. I don't know, I just see a lot of these roots here, and maybe if I cross them out, that would be kind of nice, simplified a little bit. So I will get 1 minus here and here. And then I need to think about square root of n times something gets me the sixth root of n. So root n times something gets me the sixth root of n. Thinking about it with exponents might be a little bit easier for me here. I know that you can just kind of replace the index of any of these radicals with kind of a similar fractional exponent. So this power of 1/6 is the same thing as the sixth root. Now I could employ some kind of exponent rule here, where if I add the 1/2 and this mystery exponent, I should get the 1/6. So I could subtract the 1/2 from both sides, do a little bit of, oops, that's not the right one. That's still 1/6. I'll do a little bit of fraction arithmetic, and I'm getting -2/6, which is, I guess, the same as -1/3. So ultimately, this n right here should have a power of -1/3. And I guess I'll keep it like that. I could have alternatively written it like 1 over the cube root of n. Here, this 3 kind of lines up with that 3, and then this negative sign with exponents tells you to stick the thing in the denominator. So I'll keep this in mind for later, but maybe I'll just keep it as a negative exponent. And then when I'm factoring out a square root of n from the bottom, I'm going to play a similar game where n to the 1/2 times n to the something is going to be equal to n to the 1/3. And then I think this something has got to be -1/6, because I know that 1/2 minus a 1/6 is a 1/3. Okay, so I'll put n to the -1/6 like that. And then kind of in the back of my mind, I'm also thinking, well, maybe I could have written it as 1 over the sixth root of n. And I'm not quite sure which one's going to be more helpful, but I think I'll just kind of keep it as exponents for now. Okay, so I found something, right? I can cancel out this factor with this factor. In fact, with direct substitution, this is just the number 1, right? The square root of 1 is still 1. And so not only did I find some kind of repeated factor to cancel out, they're both just the number 1. So even if this bottom one wasn't here, I could still kind of, multiplying by 1 doesn't really do much. So either way, I can get rid of these square roots of n because there is just 1 over 1 there. And I don't really like it when my variable is negative. So in this next step, I'm going to just flip-flop both of them, where I kind of just flip the positions of these two numbers. That does produce a negative sign when you flip them. But if I flip both, it's kind of like I'm negating the top and the bottom. And so something like -5 over -3 is going to be the same thing as just 5 over 3. So I'm flipping the top and the bottom, and this should not change the value of what I got. And I'm just doing this because, I don't really like it when this term is negative. It just feels weird. Okay. So if I still try to do direct substitution and I plug in a 1 here and here, I'm still going to get a 0 over 0. So I still haven't found the cancellation I need. I'm thinking, what if I try treating these as differences of squares? Now, it'll be a little bit strange, but I know that if I have a squared minus b squared, I could factor that as a plus b and then a minus b. And I'm really hoping that I'll be able to cancel something on the top with the bottom. Now let's see. If I try factoring the top, my minus 1 should turn into this minus 1 and plus 1. Here I'm kind of thinking about taking the square root of whatever term I have here and kind of plopping it there and there. And like I've said before, the square root of 1 is just 1. And then the square root of n to the negative 1/3, maybe if I think of this square root as instead a power of 1/2, I'll be able to multiply the exponents and I'll get something like this. So I'm pretty sure I could factor the numerator as n to the power of negative 1/6 in both of these spots. And if I were to multiply out the whole numerator there, I would basically just get right back to where I started. And this is actually really ideal because I have essentially just copied my denominator right here. These factors can cancel. So I can get rid of this and get rid of that. And this is this pesky 0 over 0 that I'm getting rid of. You can imagine plugging in a 1 here and here. Both of these factors would be 0 if I was plugging in a 1. But since I'm plugging in a number that approaches 1, it's not actually exactly 0. It's just like super, super close. But since they're not zeros, I can cross them both off, and I'm just left with n to the power of negative 1/6 plus 1. And I realize I've been missing my limit notation this whole time. I always do this whenever I do limit problems. I always forget to include this notation the whole way down. And let me include parentheses just in case. But here, since I've crossed off my pesky 0 over 0, now I'm pretty sure that direct substitution is just going to work totally fine. I know that 1 to any power is just 1. So 1 plus 1 gives me 2 today. And there's the answer. So stick around though, because I want to do maybe even 2 other ways to solve this, just to confirm that 2 makes sense. Let's take a look at what the function looks like. So let's just type it all out. Oops, that's supposed to be the nth root. Put a 6 there as the index. And then we have square root of x minus the cube root of x. There we go. And what we found is that when x approaches 1, the function's value approaches 2. So this spot is basically what we found. When you plug in the 1 for x, we're going to get the value 2 for y. But then if we actually inspect that point, we're going to get, there it is, undefined. Because when we plug in the 1, we did 0 divided by 0, and you can't do that. So everything around it is telling us that this value should be 2, except you can't see it with directly plugging in the 1. However, using limits and algebra and canceling factors, we found that this value should be 2, and this graph confirms it. And then for my third and final strategy, I'm going to try to see if L'Hopital's rule is going to be useful here. There's some French guy named L'Hopital. That's his last name anyways, and that's the American pronunciation of a French name, so I'm probably doing it really poorly. Where he figured out that if you're trying to find the limit of an indeterminate form, so maybe it's 0 over 0, maybe it's infinity over infinity, you can take the derivative of the top part and the derivative of the bottom part and try it again and see if it works out. So I'm really quickly going to go through some power rule derivatives and see if using L'Hopital's rule is going to help out. So I'm rewriting these again with exponential powers, or fractional powers rather, instead of these roots, because that way I can more quickly use the power rule on all 4 of these terms here. So I'm dropping this power down as a coefficient, and then I'm subtracting the power by 1. That's just kind of what the power rule says to do when you're taking these derivatives. And then, so finally, this power of 1/3 will drop down to the coefficient, and then subtracting 1 from 1/3 gives me negative 2/3. Now, this doesn't seem helpful at all initially because this looks like a real mess. I don't like fractions, right? So let me multiply the top and bottom by maybe 6. So I'll multiply basically all 4 of my terms by 6, and this isn't changing the value of my fraction. So this first 1/2 times 6 is a 3. This will be a 1. This will be a 3, and that will be a 2. There we go. And I'm just kind of copying down all of the powers of n as is. And then still, if I try to plug in, oh, wait a sec. If I try to plug in a 1, wouldn't it be fine now? Although I'm realizing something about my math doesn't look quite right. Yeah, this shouldn't be a 6. That should be a 3, right? Because I multiplied everything by 6. This turned into 6 over 2. There it is. That should be a 3. Okay, so I used L'Hopital's rule. I took the derivative of the top and bottom, and I'm trying to evaluate the limit again. And let's see if direct substitution is going to help. Now, 1 to the power of anything is just going to be 1. So all of these are just 1. And multiplying by 1 doesn't do anything. And so substituting in the 1 for n, I get 3 minus 1 over 3 minus 2. That is 2 over 1, and that is 2. So the same number that we saw in the graph, the same number that we found by canceling factors. You could also use L'Hopital's rule on this one and figure out that the limit of this expression is 2. So I'm all done for today. Thanks for coming along and solving this with me, and I'll see you tomorrow.